Good afternoon, everyone. My name is Kevin Carpenter. I'm a volunteer with CppCon, and I'm fortunate to have Matthew Butler with me today. We're going to talk to him about the upcoming class that he has coming, as well as his talks at the conference. Matthew's been working in C++ and security for 30 plus years now, I guess. You want to give us some of your background, Matthew?
Yeah, so I started in C++ before there really was a standard. I found out the other day that Bjarne wrote his first book in 1985, and I started with the Borland C++ compiler in 1990. So I'm finishing out my third decade with C++. As far as the security is concerned, I think I sort of backed into that. I started back in the day. It was called information systems. It's not IT. It was information systems, and my second job, I had a clearance, and you're in a different world where what you're writing is now sort of on the front lines. And back then we were really naive about security. And by the time had gotten to the job where I was responsible for a network, I was really on the receiving end of people wanting to get into our stuff. So that's how I got into security, was through cleared work and then through working for companies that were there to defend networks.
That's interesting. It's funny because actually the Borland C++ builder was my first C++ compiler. Jumping to MFC was definitely a different beast compared to, I
Yeah.
used to consider it Visual Basic with C++ because it was just an easy, rapid development environment, at least with Builder it was. So, so I'm talking to you because you got a class coming up uh, this month at the conference. You're doing exploiting modern C++, building highly dependable software. Is that correct?
Yeah, what we find out in the security world is that it's never the big problems that we create. We tend to be able to handle those fairly easy, but it's the little things. It's the little mistakes in code, the little mistakes where we fail to secure a particular piece of our infrastructure. So what this class is really about building high quality bug-free code, because building high quality code is a fundamental task for software engineers, but oftentimes we don't really have an understanding of how do you go about doing that from the beginning. We know how to build algorithms, we know how to build data structures, those are fairly easy, but when we're talking about security, or we're talking about software that stands up to the punishment that users put out it through every day, we sort of don't have a good understanding of how you go about doing that from an architecture standpoint, coding, code review, um, the standpoint of testing. A lot of engineers are very good about building things, but they don't really have a good grounding in testing. And that's one of the things I found early in my career, is that a really great test team will save your life every time, because they'll catch the things you forget, the things that the users will find, and certainly things that hackers will find. So this is going to be a hands-on class. We're going to start with the architecture and go all the way through testing, and look at some techniques and some strategies for how you produce high-quality code that's going to withstand what's coming at it in the field.
That's awesome. It's funny that you mentioned testing because, as much as I'd learned programming to begin with, it's kind of like testing, at least for me too, came in as an afterthought. And even the companies I've worked at, some of the, we'll say, older programmers, I've seen some of the same things. It's like, especially in the environments where the making the money came at the forefront, and the quality of the software was an afterthought. And it always seems to bite us in the end, but we get better at it as we go, right?
Yeah, and I did a tour as on a test team where I had a test and development team, and that was sort of my entry point into realizing that I didn't know anything about how to properly test a product. I was more focused on how to build it, how to make it perform really well, how to be efficient, but I didn't really have an idea of how to find the edge cases and find the things that people would find in the field. So it was a real eye opener for me, and ever since then, the way I've built software and the way I've tested software has changed quite a bit. I still have a heavy reliance on QA teams, because they're the experts in finding the things that I miss, but they find a lot less now, because I'm catching a lot of these things earlier going out, and that's really what this class is about.
Excellent. So you were in Germany for the ISO committee meeting this summer too, weren't you?
Yeah, I joined the ISO committee this year, and I was in Cologne a couple of weeks ago.
So what were some of the out of the topics and things that you heard? What were some big gains, or are there things that you're looking forward to that did or didn't come out of that from a security point of view of C++?
Well, I think it's not something that I think is directly related to security, but it certainly does help, and that is concepts. So concepts are something we were looking forward to for a long time. Everyone thought it was going to be in 17, but it wasn't quite fully baked, and so they went back and made some changes. Anything that helps a developer write correct code is always going to help you create more stable code, secure code, code that can handle whatever's going to get thrown out in the field. So that was, I think, one of the big gains we got this year was concepts coming out. And then on the security side, I think one of the probably maybe one of the gains we were hoping to get, but we didn't really get it, was in contracts, because in contracts, you're looking at ways of validating what you're passing into a particular function, and having sort of a ritualized way of handling what's being passed in. I think the concern I had, and we're addressing this better, is that the contracts that we had in there were really not focused, or really didn't take into account hardware that needs to be secure, hardware that is in critical security applications like vehicles and things like that. So there were some places where we were introducing undefined behavior, where we were going to just simply call abort if a contract failed, and that's going to be problematic for software that's written for critical systems, where you can't afford to have the software fail, but you do still want to have that check in there to make sure that what's going into that function is valid in all respects. So we're looking right now at all the use cases. We just had our first meeting last week of the new study group, and we're looking at ways that we can handle contracts, not just for critical systems, but also for general development, in a way that is secure and in a way that gives you a tool you can use to ensure that your software can stand up to whatever's going to be thrown at it in the field.
I find that interesting, just because the amount of hardware that we can program C++ on and the variations of systems. I mean, I work in financial transactions, and so yes, if our systems go down, somebody's going to be upset because they weren't able to buy a book or buy a trip. But it's not like if we have medical based systems that are tracking someone's heart rate or things like that go down, or like you were saying, even automobiles, when you look at the self-driving cars going in, you just cannot have a failure in that. And so that's an interesting aspect that I don't think we always consider.
Yeah, safety critical systems is one of those places where you sort of have to really think about what is the impact of what you're doing. And that's where the law of unintended consequences tends to be the worst, because there you really are talking about people's lives, and you're talking about crashing planes and killing people, or cars. And one of the things that a lot of the use cases we're seeing going into our analysis right now have to do with, how do we handle this in safety critical situations? Is this really applicable to safety critical situations? Do we want this only in our debug builds where we're going through test, or do we still want this in the released code that goes out the door or gets put on the hardware? So it's a complicated, like so many things in C++, there's a lot of complexity involved in trying to make the right decision so that you get a tool that works well as broadly as you possibly can. And safety critical systems tend to be one of those places where it has sort of special requirements.
Gotcha. So I hear that you're also working on a book that's supposed to come out this next year.
I am. The book is roughly parallels the teaching that I'm going to be doing here at CppCon. So this class is it's the final weekend of CppCon, and the book is due out sometime summer or spring of next year. But it roughly follows the class. And what I'm trying to do in this is taking an engineer into sort of a domain that they're really not familiar with, which is security. But in the context of writing high quality code. And one of the places we find where we're having a lot of difficulty, especially in training, has to do with undefined behavior. So I spend a lot of time both in the class and in the book dealing with what is undefined behavior, what are the practical implications for you as an everyday ordinary software engineer, whether you're doing critical systems design or not. And one of the things we find is when people look at the standard, I mean, the standard's not written for everyday engineers, it's written for compiler designers and standard library implementers. So it reads like a legal document, and sometimes you have to go 6 or 7 different places to find out what a particular facet of undefined behavior means to you as an engineer. So one of the things I'm hoping to do is sort of demystify that and put it into terms that are easier for engineers to see, maybe be able to just look up, okay, well, I'm using this particular feature of the language. Where are the sharp edges and the punchy sticks and the shredded glass that can cause my systems to fail? And then we also go through, the book will also do a lot of the same thing of how do I use static dynamic analysis, dynamic analysis, fuzz testing. How do you do a proper code review for not just making sure the code is doing what it's supposed to, but also looking for those edge cases where you can potentially fail in the field because of either something that a user did or something that someone did that's malicious.
Excellent. I'm sure I will be looking forward to it when it comes out. So you're, I guess the last thing I want to ask, because I was thinking, I know you got a talk coming up at the conference this year, and so I want to, I don't have the title down, so I don't remember, but I remember seeing your talk last year, which was absolutely excellent. And so if
Thank
that's
you.
any indication, I'm certainly looking forward to see what you have this year. So tell me about your talk.
So this one's a little bit different than the ones that I've done in the past. It's called "If You Can't Open It, You Don't Own It," and that comes from hardware hackers. And so what I did is I took 4 hardware super hacks. These were ones that were, a lot of people will come in and say, "Oh, you're giving the scary talk," that you're going to scare people. And my thing is always, if you come out of my talk scared, then either I have totally miscommunicated with you or you are getting the wrong conclusion. I love seeing elegant hacks because they tell you a lot about how people think about our systems. And so, we've had Meltdown Inspector and Foreshadow. And so those are examples of side channel attacks. And that's one I use. But there's also things like roots of trust and supply chains and physical access. So I take these 4 hardware hacks and show you exactly how they did it. And then I apply those lessons to software and how those affect the software world that we live in. But then we're going to also talk a lot about C++20. What's coming down the pike in C++20 that can either help us or not help us when it comes to security and stability in our software and being able to write high quality code. So it was a fun talk for me because hardware hacks are just a lot of fun to do in general. But it also sort of opens the door to what are the lessons we can learn as far as how our codes will perform in the field, and then what kind of things can C++20 do for us. So the talk is Monday, I think at 2 o'clock in the afternoon, so it's right after the opening of the conference.
That's excellent because I'm also done with my volunteer session in the morning and haven't started my one at night, so I can definitely make that. And so,
Cool.
so I look forward to seeing you at the conference here in just about 4 weeks out now, I guess. And I appreciate you taking the time with me today to catch up.
Yeah, thank you. I'll see you in September.
Thanks. Talk to you soon, Matthew.